Our next speaker is going to be discussing the IPv6 routing table in 2010. Jim Cowie from Renesas.
Thanks. When I proposed doing this talk, this is the first time I ever stood up here and did a V6 talk. Right? You've heard me do a lot of V4 talks. First time on a V6 talk. So somebody actually told me I would rather be poked in the eye with a sharp stick than see another state of the V6 table talk. I thought that was a little bit uncharitable, but there's a reason for it, right? We've seen a lot of these. We've seen this happen before. Today I'm going to try to do something a little different than you normally see. What we're going to do today is, instead of the classic thing where you see the prefix count in the V6 table creeping up, we're going to take a look at the V6 table and its participants in terms of the V4 table, where I know a lot more. And you'll forgive me if I mess up some of the V6 language, because I haven't really been following it. What we're going to see today is we're going to look into the V6 table, find all the ASs, find all the relationships between them, and then go back and try to explain that structure in terms of what they're already doing in the V4 table. Then we'll take a look at what kind of prefixes they're advertising, how reachability is shaping up, whether it's just a bunch of islands. I'm going to figure out something about how long a prefix you can have that will generally be reachable in the V6 table. And again, I think the previous talk shows it really clearly. That's where all the hard work is. This problem isn't going to go away. We've all become resigned to the problem. When V4 gets exhausted, this will have to be fixed. So the question, classic question, is what took you so long? Well, we had to move all the V6 haters out first. So Renesas has been looking at this problem for 10 years, okay? Watching it. It's been a long time. Occasionally somebody would pop up and say, you guys study the V6 table too? And we'd say, well, we could. We've got some interest now. It's only in the last 6 months we've really had enough of you coming to us and saying, hey, we could V6 peer with you now, that we have enough full tables to really start doing with V6 what we've always done with V4, which is mine it for relationships and figure out what's going on economically and with some trending. And as I'll show you, we still don't have enough data. There's a reason why this is the first talk that we squeezed out of this. So anyway, let's give it a shot for what it's worth. The first thing you should think about is the implications of the fact that the way this is going to work is that there really are two tables. It's not one table. There was a decision way back that V4 Internet was not going to be embedded in V6. We were going to do it again. And so there are two internets. One of them is trying to turn into the other one, is a way to look at it. To avoid disruptions in the way that this happens, if you want the end product to look like today's Internet but better, almost all of the business relationships that built the V4 Internet are going to have to port over to V6 or go away. The existing Internet really grew organically, and I think one of the reasons that there's a problem here is that there weren't enough people at the decision point originally who had launched, who had tried to build a social media company and failed. Okay? We did a little of that. It's really hard to make large numbers of people do what you want, no matter how cool the technology is. Right? Adoption has to be drawn based on what people's own self-interest says once you get beyond some scale. So is it possible to replicate the existing V4 Internet piece by piece by piece in the V6 space? It's really something that if you look at the graph of autonomous systems and their relationships, you should actually be able to kind of sense how far along that replication curve we have come. So in terms of reasonable expectations, the reason we're not going to talk a lot about prefix counts is that we expect the V6 table to be much, much, much smaller. It's part of the purpose of this whole exercise was to aggregate better and to have fewer little tiny things floating around, keep the table size down. But as I said before, autonomous systems are different from prefixes. Every autonomous system represents some organization that made the commitment to get themselves on the Internet and get registered and potentially be multi-homed. If you expect the V6 Internet to converge to fewer autonomous systems overall, you're going to have to tell all those people that they're giving up their economic choice to have the potential, at least, to multi-home. And may have been possible before. In this day and age, there's tens of thousands of organizations that are probably going to dig in their heels and say, I need multiple providers. I need PI space. I need to have on the v6 internet the same kind of economic freedom to choose and replace my transit providers that I had in the v4 space. If you just take a look at the bare numbers, you know, there's 34 to 35,000 autonomous systems in use in v4, and the breakdown is, you've seen this breakdown in my previous talks, 40% or so are single-homed, 40% or so are dual-homed, and the 15% of them that are in this room are triple-homed or more. So that's a lot of relationships, right? Every provider-customer relationship, every peer-to-peer relationship has to get ported potentially to v6. Now in v6 so far, only about 1 in 16 of the v4 ASs have actually made the trip and show up in the full table. And of those, about half are single-homed, so it looks kind of the same in terms of distribution. As I'll point out, we have a paucity of data to really understand the economics of a lot of those relationships. In v4, it's large enough, there's a lot of context. We can often infer, based on context, for every pair of ASs in the table, which way does that relationship go? Who's the provider, who's the customer, or are they equals of some sort? In v6, there's less information to allow you to make those inferences. So what we're going to do is take a look at the two graphs together and think about whether or not we can understand the v6 edges in terms of the way that relationship looks in the existing internet. So if you look at the edges in the graph, remember the nodes are ASs, the edges are AS relationships, adjacencies in AS paths that are witnessed. There are at least 107,000 edges. Okay, the majority of those obviously are transit. A substantial minority are peering. That's a lower bound because that's what we personally see with hundreds of peering sessions integrated over a long time. As Randy Bush will tell you, BGP is an information hiding protocol. There's more edges than this. These are the ones that we saw. Each one of those is a negotiated or contractual relationship, which again is either going to have to die or get ported. How are we doing? Well, take a look at v6 ASN graph. 1 in 13 edges has ported. I think that's actually pretty good. But look at the distribution. About 2,200 of those exist. They're transit edges in v4. They're probably transit edges in v6. A much larger number, 3,800 edges, are peering in v4 and presumably also in v6. 29% of them have never been seen before. Holy cow. So closing in on a third of all the relationships in v6 are novel. What does that mean? There's at least two possible interpretations here. First of all, if it's real, it means that we have a serious discontinuity in how people are buying internet transit when they think about buying v6 transit. It may mean that people can't get v6 from the people who sell them v4 transit. And that should be worrisome to those of you who sell v4 transit but don't sell v6 transit, because there are other providers who are stepping up and selling it. And the other alternative explanation, of course, is that all these new edges are just experiments. Somebody's doing AS adjacencies over tunnels. Somebody is, getting their feet wet with v6, but you shouldn't take it seriously economically. So let's take a look at these new edges that crept in. So over half of the ASs in the v6 table have at least one adjacency that has never been seen in the v4 table. If you look at the organizations who are the magnets for these new relationships, there's no surprise. The guys over at 6939 have been setting things up. Over 400 new adjacencies that we witnessed that just don't exist in the v4 land. TINet at their heels with over 130. And then there's a long tail. Most people, of course, the average person has just one fresh v6 connection that he ginned up so he can get on the v6 net. As you think about this, it's what you might call a success breeds success growth pattern, where if somebody walks up today and they're a neophyte and they want to join the v6 internet, it's like in the old days. If you wanted to join the v4 internet, you went to where there were providers who had large numbers of adjacencies and were sort of demonstrably healthy providers, and you would go there first. There may be a similar thing kicking in the v6 net if you take those edges seriously. If you look at the people who are adding adjacencies out of these ASs, this is unusual. Look at the distribution here. So 7% of them are brand new. People maybe got ASs that they're just going to use for v6. Maybe it's a mistake. 17% of them are single-homed, 28% of them dual-homed, 46% of them triple-homed or better in the existing internet. Okay, so now this tells you who these people are who are ginning up new relationships on the v6 net. They're not, your typical bank in Idaho or something. These are sophisticates. These are triple-homed, possibly transit providers themselves, seriously trying to build out core infrastructure. So you have to ask, where's the v4 edge, right? All the people that aren't here. Out of the 34,500 IPv4 ASs, of course, the vast majority, 29,000 of them, don't have anybody downstream. About half of those are multi-homed. If you look at v6, you see something else very strange. People who have nobody downstream of them represent 84% of the v4 net. They only represent 46% of the v6 net. Okay, so this is an inversion. It's telling you that there's a population of ASs that are not getting into v6. They're running the other direction. So you have to ask yourself, is there some misalignment of incentives, or are the people who are at the edge witnessing some disincentive to get themselves over and get registered in the v6 space? Here's a visualization. Oh, good, it shows up well. Think of the IPv4 AS space as a solar system. Okay, it's a cheesy graphic, but the purple dots towards the center are ASs. Each little pixel here is an AS. The purple dots have downstreams. The blue dots do not. Okay, and the purple dots that are closest to the center of this diagram have thousands of downstreams. They're the core guys. As you go out, these are the rings you see are people who have 3, 2, 1 guy downstream. And blue is nobody downstream. Blue is kind of like the Oort cloud of little frozen objects that orbit, the V4 solar system. Look at the V6 solar system. Here's the exact same pixels in the exact same place. Here's the guys that have shown up in V6. Can you see it? It's kind of a little thin, peppery scattering of dust. But actually, it's kind of entertaining because if you look, there's actually really good coverage here in the core. Out around the edges, it's pretty sparse. Okay? Only 1 in 16 of the dots in the previous slide have made the leap to v6 space. So all the people who can be converted to this easily have already made the jump. Here it gets hard. Put these together, and I blew up the red IPv6 dots very big into big GNU plot crosses so you could see where they were. Because otherwise it just looked like a blue plot. Here's the embedding of people who are v6 capable in the old IPv4 internet. Again, the core is pretty red. The Oort cloud of all the blue dots with nobody downstream of them is still quite blue. Another way to look at this, I went back to Renesas Market Intelligence and pulled out the rankings of people by their customer base, on each continent. And I pulled them out into cohorts, and I said, what percentage of our top 20 people in North America are actually v6 capable? It's 90%. And that's what you see across all the continents. Down the first column is you see, well, except for South America, it's 70%. You see 85, 90, 95% of the top 20, the 20 biggest ASs serving a continent, doing v6. That's great. Go to the top 100. Well, now we're down to, well, in Europe, 70% of the top 100 ASs in size are doing v6. In Asia, 58%, Australia, 57%, but, North America, 45%. You're in the minority now. You go to the top 1,000, imagine the top 1,000 biggest ASs in a continent, and you're really dropping. And if you go to the entire space of everybody, all the ASs serving a continent, you're looking at 6% of North American ASs. Pick an AS at random, he's got a 6% chance that he's also in the v6 table. And on Earth, it's 7%. The bright spot here, of course, is Africa, where if you pick an AS at random who serves any African prefix, there's a 1 in 5 chance that he does v6. It's pretty cool. I said I wasn't going to talk a lot about v6 routes, but at this point it makes sense to go ahead and say something about the distribution of prefix lengths. Because of the way v6 is set up, you are going to see very strong resonances, stronger even than you see on the old CIDR classical boundaries in v4. Fully 51% of the full table, and maybe I should tell you what full means. 51% of a very full table, counting generously, are 32s, as you might expect. A good 25% of them are 48s. And then you see some resonances at 40 and 56, but that's basically pretty much the picture. So there's a critical question here about visibility. Whenever you look at the table, you know, there's lots of routes in the table, and no matter how you construct your definition of a full table, there's going to be a lot of routes that are only seen by a peer or two. There are more specifics that only they show their customers. They're showing you because you're a data collector, but it's not really meant to be globally visible. So we'd like to figure out what global visibility means, which is, of course, hard. We want to figure out what the equivalent to /8 and /24 might be for IPv6. Well, mostly the equivalent of /24. And this is important because you need to understand how the routing table size is going to grow. Keeping the routing table compact in v6 was a driving core principle, and we want to see how the availability of more specifics in the v6 table is going to grow the table in the future. And as I say, it's very hard to tell when something is globally reachable with capital G, capital R. And you basically pick your rule of thumb and you work with it. We use one here that's sort of common sense. If I pick a peer at random out of my hundreds of peers, I want at least a 90% chance that they see a prefix. Then I'm going to say, yeah, if I go to a random place on the internet, I can probably reach that prefix, 90%. So the way that v4 internet works is you get really good agreement on basically a large range of lengths. You get 80 to 96+% of reachability for things on and off classical boundaries from 90% of peers. And that's good. That's what you want. That's what the internet is, right? It's a rough consensus on filter settings and agreement that things that are generally visible can be generally held to be visible. So in v6, it's good for 32s, 92%. That's on a par with the best of v6 or v4. It goes down from there a little bit, and primarily this is because you're mixing PA and PI space prefixes, right? In v6, you might not expect people to pass things longer than a 32. That's how it was set up. They're supposed to kind of go away. And so the reachability for things like a 48, which is 48, portable 48, is where we expect to see the ORT cloud show up when they finally make it onto the v6 net. 67% reachability. So it's not quite as bad as that, because if you go back and just look at the PI space, remember PI space in v6 is a fairly young concept. I don't think there was going to be a lot of support for PI space originally, and then it became clear that not everybody wanted to become an LIR in order to have their own space. And people started going out and saying, you know, okay, Afrinic, I remember, set up a policy and said, we're giving out some PI space, you know, create a swamp. And the difficult thing was that then there were very large providers, very, you know, top-tier providers who I won't name, who said, well, we're not going to propagate those 48s because they're longer than 32. And there's no RFC governing this, and there was a lot of thought that went on basically over kind of the same timeline that you saw in the previous talk, 2007, 8, 9. And so finally today we have a really good result, which is that 94% of all the PI allocations that I was pulling out, just seeing who was underneath each of the filter nets, are actually reachable. You know, it's a great result. The color codes here show that the different lengths that have been shown up, and that are showing up in the v6 table from each of the registries. At each length, you see that the gray, of course, is 48, so the vast majority of what's going out showing up is 48s. But especially at APNIC, you see a great diversity. There's some 32s, some 42, 36, 35. There's a little bit of everything. And all of them have really good reachability. That's a great result. You just wish there were some more of them, because we're still talking about hundreds of prefixes. And remember, we have 107,000 relationships that have to get ported. And so my summary here is that we have to figure out how to re-incentivize the edge. 6% of the relationships show up. And there's a significant bias here. We're preaching to the choir. The people who are getting recruited here are the people who are already highly multi-homed, who know that this is necessary. The non-provider enterprises are the ones who are staying away in droves. 3%. If you say the ones who really are sophisticates, the multi-homers, it's 4%. Okay? The only other interesting thing, I just want to say it twice, 29% of the relationships in V6 table are new. Again, that may mean that people have some dissatisfaction with existing transit providers who can't get the V6 support that they're asking for. It's actually kind of coincidental that this makes the NANOG meeting attendance look kind of similar to the V6 table in the sense that 29% of the NANOG attendees are also first-timers. And the rest of them are sophisticates. I don't know. It's a bad analogy. It's just clear that we're still in the early days. I'm going to have to do this talk again and again. IPv4 is a huge, rich ecosystem that's going to take time. It's like taking the United States and rebuilding it street by street on the moon. You know, this is going to take a long time. So I exhort you to peer with us, of course, so that we can keep watching, see what's going on. So I conclude. Questions?
Jason Schiller, Verizon. On slide 20, I think you seem to suggest that there's not a lot of reachability to /48s in general. And then on slide 21, you seem to suggest that reachability to PI 48s and larger seems to be quite good.
Right.
So is the corollary true, which is that PA 48s generally don't have good reachability?
Yes.
Thank you.
You got it right. That's exactly what it means. Sorry I didn't quantify it. Randy.
Randy Bush, IJ. Jason, there are significant large V6 providers who will not route PA space out of their own space.
Yep.
Whether that's a good thing for V6 multi-homing and V6 in general is an interesting topic for discussion.
It certainly is.
Leo Bicknell, ISC. I'd like to bring a couple of different perspectives there because I think it helps explain your new and novel and some of that kind of stuff. I work for a root server operator, and the first thing I'd like to point out is that while there's lots of wonderful argument over PI and PA, and I don't want to step in that minefield, there are also micro allocations. And we have lots of 48s that have root servers in them that people might like to get to. So, you know, not all 48s are Joe's bait and tackle.
Yep.
And also, not all micro allocations are 48s. The root server I work for sits in a 47. So if you like to allow 32s and 48s, you're still missing the boat. And there are numerous other examples. You can go to the RIRs and pull them. But on the new and novel front, we do operate servers in 50 locations around the world right now. Mm-hmm. And we have a goal to IPv6 enable all of them. They are not all IPv6 enabled for various reasons. You know, if you want to IPv6 enable something in Amsterdam, you pretty much fall over people offering you free IPv6 transit. And if you want to enable it in Kuala Lumpur, it's a little bit of a different story. And so people like us, who have Clue and lots of friends in the room, turn up all sorts of weird tunnels and other stuff to make things happen. Right. And I suspect what you'll see is many of those new and novel isn't that we're dissatisfied with our peer, it's that we really do want to lead them, and those things will go away. It's not an attempt to bypass them or find some new, better transit provider. It's just, in terms of adoption, the core has to be there before the enterprises can jump. And I keep hearing this in the Aaron and NANOG forums, you know, this blue edge, as you describe it. We've got to go encourage them. Yeah. I don't know why we have to encourage them. We have to get our piece done, and when they need it, and you can all come up with your own driver, they'll buy it, they'll ask for it, they'll whatever. Right. I don't think there is any encouragement. There's no amount of going and talking to Bob at Joe's Bait and Tackle and saying you really need to enable V6. Well, at some point he'll need it because he can't get space or his new application needs it or whatever. We better have our piece done way before that so he's confident we can do it.
The funny thing is that Joe's Bait and Tackle already did this once. He thought he was done. He got an AS, he got some address space, he pays fees every year, and he's all good and ready to go. And why, I got to pay again?
And the thing is, though, for a lot of those organizations, he may be done for 10 more years.
Right.
Because V4, this is the problem. V4 doesn't stop working. Even when everybody's out of address space, he keeps on working for some period of time. Eventually, he'll have a driver. And I think there's an awful lot of energy being expended trying to convince these people to jump today.
Yeah.
And I really think it's misplaced. We're spending a lot of our resources on something that doesn't make sense to him. And we just need to give it some time. That it will happen in due course for a variety of reasons outside of our control.
Good points, all. And in terms of microallocations, we have seen stuff as long as 64 with really good reachability. So, but it has to be PI space. Todd.
Todd Underwood, Google. On slide 3, you seem to, first of all, make an unauthorized commercial use of my image without, I think, any compensation that I'm aware of. So, on the one hand, some remaining equity stake I have in Renesas might prohibit me from suing you, but I have to check the shareholders agreement. And I can't decide if it's a compliment or an insult, but as soon as I do, if it is an insult, it may be slander as well. So I'm just letting you know.
Thank you, Todd.
For the record, even though I'm a well-known hater of the V6 and liken it to a sexually transmitted infection rather than a networking protocol, I did turn up the first V6 peers before I left Renesas, so...
That's true. We owe all of our V6 collection infrastructure impetus to that man right there. Yes. Cool. One more.
Jason Schiller, Verizon. I agree with everything that Leo just said about the edges coming later to the game, and when they need V6, they will come, and we really shouldn't be in the position of encouraging them to plunge feet first into IPv6 now. However, I think it is important to give them a little wisdom and to give them a little guidance and caution, and that is the day will come when they need to do V6. And they need to plan for that so that when that day does arrive, there's not suddenly an emergency and a problem that they haven't already solved. So what I've been recommending to our customers is to, yes, go ahead and do V6. If your equipment doesn't currently support it, go out and buy some equipment that does. Make a minimal investment. Set it up in a lab. Set it up in the corner of your network. Figure out what your V6 configuration is going to be, what your addressing plan is going to be. Make sure that V6 is going to work in your particular architecture and deployment. And figure out all of the things that are broken in your back office, which tends to be a very long pole in the tent. And scope how much time and how much cost it's going to be to get you to be V6 ready. And at least do that minimal work so that you know what you're looking at in terms of cost and time to be V6 capable, so that when you do see that finish line of, oh crap, we really do need to do V6 because there's some V6 network that we suddenly do need to talk to, or suddenly our need for IP addressing is once again growing and we've run out, so that you're basically ready for that transition.
Yeah. It's a long process, and people don't get off the dime unless they see it. It's going to take. If only somebody would give out stimulus checks for $1,000 to become V6 ready. No, seriously, figure how much would that cost? Multiply it out. It's 35,000 people. That'd be cheap. Let's do that. Oh, sorry.
Yeah. Matt Poundset from Affiliates. You're asking earlier on in here if there was some sort of disincentive for the edge networks getting on, and some of this they already mentioned it's more of an absence of an incentive, right? The way the rationale goes, I've talked to a bunch of sysadmins and network admins for enterprises through Sage lists and Lopsa and stuff like that over the last couple of years, and the rationale usually goes something along the lines of, well, we never need new IP addresses. Everything we have sits behind a NAT. So we don't have to worry about getting V6 in order to put stuff on the network. And, everybody who's already online has v4 addresses, and they're not going away, so we're still going to be able to talk to them even after the runout occurs. And so they're just looking at it as, it's just, maybe in 5 years there will be some little tiny percentage of the internet that I can't reach because they're only on v6, but it's going to be a tiny percent, and it's years away. And that's just kind of where they sit right now. And so, like Jason says, there's probably some value in putting effort into encouraging those people to start thinking about it, but there's absolutely no value in them actually making the leap right now.
Well, it's accurate. Okay. Maybe last question, and we'll wrap it up.
Owen DeLong, Hurricane Electric. We have some visibility into the some of those new relationships you were talking about, and
Yep.
I can say that a lot of them are people that have trouble getting v6 services from their existing relationships, or simply feel that they can get a better v6 experience by choosing a provider that has a bit more v6 experience.
We see you in the stats. I think we're...
One more. John Curran, Aaron, I'd like to reply to some of the prior speakers regarding v6 incentive. So try to make this short and simple. You can tell someone you should look at v6 so you can be ready for when you need it. But in the list of priorities, whether it's a small business or a large business, looking at something so they'll be theoretically ready is always going to fall below fixing real-world problems. So a lot of these organizations actually need a hard, tangible goal to work for, and it's not turn on v6 throughout your organization. That's not it. As someone said earlier, all their devices are behind NAT. They don't need new addresses. It's not a problem for them. But their public-facing servers, their web server and their mail server, in particular their web server, is going to be accessed by people increasingly by v4 and v6 users. And if they just maintain it on v4, then they're eventually going to have trouble, because the connectivity over the next 5 years for a v4-only website becomes more and more convoluted as the rest of you are using v6 to hook up customers. So if you want a simple goal to say, if they'd like an end-to-end packet connection, they probably want to dual home their public websites and begin working on that. And that's a tangible goal that doesn't require all of the desktops, doesn't require going inside the firewall. It does require them to talk to ISPs, to get their DMZ firewall running, to figure out their mail and their web servers. This presently is what Aaron is telling people, based on what I've heard at the Aaron meetings, is please get your websites dual-homed v4 and v6. Now, if that's not the right message, there are these Aaron meetings and mailing lists that I need all of you to respond, because I have no choice. I talk to dozens of people every day about this, and I want to make sure the message we're sending as a community is the right one.
Is there time for a brief comment? Brief. Yeah. Lorenzo Colletti, Google. I think there's no, really, there's not surprising that the networks that are moving to IPv6 are the ones that are going to face, big problems first. So it's basically a scaling issue, right? So small enterprises might not need that for the next few years. And it's interesting to see that this is actually borne out by your statistics. Like the big networks in the core, they're doing their bit. If you look at the residential ISPs, it's Comcast, right, and it's AT&T that are looking at it. If you look at the content providers, people like Google and Facebook, that are leading in charge, right? And maybe it's just natural growth, and the big networks have to face this problem first.
We can hope that that's true, that the adoption curve looks like the adoption curve for something like a consumer good, where the early people suffer, and it's expensive, and that's you. And the other guys are free riders, and they creep in. I just still don't own a DVD player. I'm one of those.
We got to, sorry, if you can take your comments into the hall later, we got to move on. John Curran from let's give him a hand.